And example 1 is basically a question from grade 10 and 11. You've got 7 plus 2 sine x equals 4 sine x plus 5. If you were solving for x, and the domain here is from negative 360 to 0, that first part you just need to, let's get sine by itself. So if I subtract 5 from both sides, I would get 2 on the left. If I would subtract 2 sine x from both sides, I get 2 sine x on the right. And getting sine x by itself, I get sine x is equal to 1. Now where on your pie plate, since this is a non-calculator, do you have sine x equal to 1? Sine is x or y coordinate? Y coordinate. When is the y coordinate 1? Pi over 2. Now you're going to naturally do this. This is not the right answer. Okay? You're going to naturally do something like this. Okay? First of all, you told me the answer in radians. Is this question in radians? No, this question's in degrees. So then you might go, oh, well, if I wrote it in degrees, I should have said 90 degrees. Secondly, when you solve something from your pie plate, you're going to naturally think about the first time around. You're going to pull out your pie plate, and you're going to go, there it is, at 90 degrees, pi over 2, the y coordinate's 1. Okay? The thing that we have to do in these questions is after answering it, because you're going to naturally answer it the first time around, you need to make sure that you look at your domain. Our domain says to look between negative 360 and 0. So that's once around in the negative direction. So now we have to think, if the answer was 90 degrees in the positive direction, what angle would be coterminal with that in the negative direction? Negative 270. So again, after second attempt, we get another answer that wasn't right. Okay? But that's okay, because that helped us get to our actual answer, which was negative 270 degrees. All right, so maybe after all of that, I'll just write negative 270 degrees here and put a circle around it, because we've solved that correctly now. Now, still part of part A, it says, then write the general solution. So if I go to write the general solution, well, how did we, if we go back in our notes and we say, what did we write down for the general solution? For the general solution, it said, solve first between 0 and 2 pi or 0 and 360 degrees, which we did, right? Here is the answer between 0 and 360 degrees. It was 90 degrees. That was the only answer. And then once you have all your answers from 0 to 360 degrees, then add 360 degrees times k, or if it was in radians, that's where we added 2k pi. So now we can write our general solution. Our general solution would be the 90 degrees plus 360 degrees times k, where k is an integer. Now you might see in the textbook on a question like this, they might have this answer. Can you see why this is the same? It's just another coterminal angle, right? In fact, what this angle is could be any coterminal angle, right? And again, if you wanted to be really mean to me, you could think, oh, I'm going to write down 3,700 and, no, that wouldn't work, but 3,690 degrees would work, yes. And you'd have to, and then you'd make me figure out if that was correct and coterminal to begin with, and then I'd have to go back and say, yes, that's good. Okay. The danger is if you increase your chances of making a mistake there as well. But so Now, the only reason the textbook might have the negative 270 is because in part A, they led you to that answer, so they might put that answer in as the answer to the second part. All right, question, part B. Completely different question, so I'll take it to a new page. Use algebra to determine the general solution, so this is important terminology here, of the equation cos 3x minus 1 over the set of real numbers, then list the roots in the domain from negative 2 pi to 0. What does that remind you of? The equation cos 3x equals negative 1, we gave this kind of question a special name. Do you remember the special name? Now, one of the reasons I give you special names, right? This is a multi-revolution question. One of the reasons I sometimes name things, like we've had triangle questions, this is a multi-revolution question, is if you can recognize something and give it a name, you are going to be that much more able to remember how to do it. It's just a memorization / learning technique. If you can give something a name, you can remember more things about that because you can name it. If you can't remember its name, right? If you're like, I don't know what difference of squares is, then you're not going to remember how to factor that when you see it. But if you can remember difference of squares, you're going to be that much better at remembering how to factor it. So, recognizing first this is a multi-revolution question, by saying multi-revolution question, that should trigger for you how to solve this. Okay? How did we solve our multi-revolution questions? We solved them first between 0 and 2 pi, and then solved it over the domain that we needed to. So if I made x between 0 and 2 pi, then 3x's would be between 0 and 6 pi, which is 3 times around your circle. And if I was solving cos 3x equals negative 1, yeah? Right. We'll get to this. I know that this part here doesn't have the equal sign right now. We'll get to that afterwards when we translate the answers we get into the domain that we have. Okay? So I'm going to first solve it between 0 and 2 pi just to see what the answers would be between 0 and 2 pi. Then you can make coterminal angles to figure out all the other ones easily. So if I solve this first between 0 and 2 pi, where on your pi plate is your x coordinate negative 1? That's right. Our angle is 3x, so we would write 3x equals, because we're solving for the angle. And when does the angle give us an x coordinate of negative 1? That's at pi. That's the first time around. Second time around would be 3 pi. Third time around would be 5 pi. And then we can solve for x by dividing each of them by 3. And we get pi over 3, pi, 5 pi over 3. This is between 0 and 2 pi. Okay? Are those our answers? No. What do they want us to do? They want us to find the general solution. Okay? So let's do that first. To find the general solution, we would take all of our answers, pi over 3, pi, and 5 pi over 3. Since this is in radians, we could add 2k pi to each of them. Where k is an integer. Excellent. Now this was with multi-revolution questions and the general solution. If you go back to your notes when we did this the other day, you'll notice I did 2 methods for solving it. This was method 1. Solve first between 0 and 2 pi, and then add 2k pi. Okay? Now, part B to this, it said solve for x in the domain from negative 2 pi less than or equal to x less than 0. And here I made sure that I remembered that that 0 didn't have that equal sign. So now we need to find out what are the coterminal angles, because we solved between 0 and 2 pi, but now we need to go once around in the negative direction. Yes? Yes, thank you. So now solving for x, we figured out, I'm going to just scroll up a little bit so we can see them, that between 0 and 2 pi, we had pi over 3, pi, and 5 pi over 3. So again, it's sometimes helpful to take out your unit circle and say, here's pi over 3. In the positive direction would be going here. What angle would that be if I went in the negative direction? And can you see that when I go in the negative direction, it gets me into like the 4th negative quadrant? And so it's going to be negative 5 pi over 3. Because 5 pi over 3 is my pi over 3 family in quadrant 4. So if I go 4 negative quadrants, it's going to be negative 5 pi over 3. And over here at pi, this one's really easy to see that it's going to be negative pi. And finally, at 5 pi over 3, it's pretty easy to see that that angle right here would be negative pi over 3. All right, questions for practice? 4, 8, and 9.